Okay, so the question I'm going to look at now is, this is all about algorithms, and this is a question for 2 marks, and this happens to be the AQA 2018 paper, but it could be any exam board really, and any year. I've seen this question come up a lot. I've taught AQA Computer Science for many years, and this question is very popular. So the question says, define the term algorithm. Now, it's very easy to jump in and go straight into this question, but you need to think about this carefully. So some people might write a sequence of instructions now. It might not be a sequence of instructions. It might contain iteration, it might contain selection. So instead of writing sequence of instructions, I'm writing a set of instructions to, and we can write solve a problem with a finite number of steps, and that's perfectly adequate. That is 2 marks there. We could also write, instead of to solve a problem, we could change that to for example, complete a task. But the point is that it does have a finite amount of steps, and when you've finished, for example, an algorithm might be brushing my teeth. When I've finished brushing my teeth, I stop brushing. Okay, so there's a finite number of steps, and it usually is to solve a problem. And I've written a set of instructions rather than sequence. Now, as exams get more and more advanced, I think this language is going to be more and more important, so it's important to start using that now. Rather than sequence of instructions, which we wrote for many years, we write set of instructions. Let's look at this next question, 1.2. The following are computer science terms labelled A to E: abstraction, data type, decomposition, efficiency and input. For each of the terms in the table, write the label the most suitable computer science term. Use the label only once. Breaking a problem down into a number of sub-problems. Right, well, that isn't abstraction, that isn't a data type, that's decomposition. So when I break my problem down into sub-problems, it's decomposition, decomposing a body. It's breaking it down. Okay, I'm breaking down the problem into sub-problems. Abstraction is something quite different. Now, the process of removing unnecessary detail from a problem, that is abstraction. And the best example of that is the tube map, where the detail of the distance between the stops has been removed. Other details have been removed from the tube map. It's been vastly simplified so that it can appear on a page and that it's easy to read. So next point, defines the range of values a variable may take. That is its data type, whether you define that as a string or an integer, or it's a real, where I can have a decimal point for currency, for example. It defines the range of values that the variable can take. So if I've specified that it's an integer and I try to type my name in there, it's not going to take it. Okay, so that is 5 marks, and that is what an algorithm is, a set of instructions, and that is looking at different types of, with the algorithm, different terms there, what they mean. Okay.